So our next learning objective in the study of polar coordinates, it's just like when we first learned radians. Radians is another way of talking about something we've done before, degrees. So one of the first things we did is go between radians and degrees, all right? Because if we have one, we want to talk about the other one. So this is what we're going to do for the next two learning objectives. In this learning objective, we're going to take a rectangular coordinate, so that's our normal xy pair. We want to rewrite it in polar coordinates, which is our r comma theta. All right, so to do this, we're going to use our understanding of trig. So based on the unit, you can know there's going to be some trig at some point. We didn't use any in the last learning objective. I've used radians, but that's not technically trigonometry. All right, we're going to convert a point into polar coordinates. All right, so let's think about the point 3, 4. Again, we're back in our traditional rectangular coordinates that we've been using for a really long time. So we go right 3, up 4, and that's going to give us this point here. But what is this in polar? In polar, I think about going along a straight line here. So in polar, I need to find two things. I need to find the angle that I'm traveling at, and I need to find the r, the distance that I traveled. And the very common thing we're going to do when we're doing this is making right triangles. And I can label some of the sides of this right triangle because I know I went a distance to the right 3, so that side of the triangle is 3. And I went up my y value, 4. So my x and y value help me label two sides of this triangle. And now I can use some previous things to my advantage. Well, the first thing I can use to figure out the r value is the Pythagorean theorem. I know two sides of this right triangle. I can figure out the third side. And I'm going to do all the work because the 3, 4, 5 is the one that comes up a lot because it's the most convenient one to use. So the radius is 5, or that r value that I'm walking. And then what is the angle? Again, this is going to use some previous knowledge that we've learned in this unit. How can I figure out the angle of a right triangle? I can use the inverse trig functions. So I know if I were to take the tangent of this angle theta, I'm going to get opposite 4 over adjacent 3. I can rewrite this using my inverse trig functions, and that flips those two things. And my theta is going to be tan inverse of 4 over 3. All right, in our first video about polar coordinates, that angle, that theta is always in radians. So if we're doing this, our tan inverse is going to be in radians. So just make sure your calculator is set to that setting. And then I'm going to do 4 divided by 3. And I get theta is 0.93. And now I can put all that information together to get my polar coordinate. I go at distance 5 along the angle 0.93 radians. And that would also give me this dot there, but in polar coordinates instead of rectangular coordinates. So go ahead and try this one on your own. I convert the point 8, 6 into polar coordinates. And this is what you should get. So you find the point, you can make a right triangle where the bottom, the x kind of side is 8, the height is 6. I use the Pythagorean theorem, you figure out the missing side of that right triangle is 10, which actually gives me the distance I have to go along this angle. So now I know my r value is 10. And trying to find my angle theta, I have opposite is 6, adjacent is 8. So I use arctan tan inverse of 6 over 8, and I get my theta. And again, putting those two things together gives me my angle in polar coordinates. Now we're just going to work with negative values. So I'm going to convert negative 2, 5 into polar. So negative 2, 5 is going to be up here. And I can kind of make a right triangle with that point. All right. One thing's not really going to change. To figure out my r, I'm still going to use the Pythagorean theorem. All right, r squared, I went 2 to the left and 5 up. I take square roots. In this case, I don't get a perfect value, so I'll take the square root of 29. Square root of 29, and I get 5.39. So that's not much different than what we did before. right, but the next part is going to be a little bit different because what I need to do is figure out what angle from my initial side did I travel. So I'm trying to figure out this angle theta there. But that angle theta that I just wrote in blue is not part of the right triangle. But what I can do is use my right triangle to figure out this angle, just call it alpha or something. And you can see alpha and theta combine to give me the full half circle. All right, so what I'm going to do is I'm going to figure out alpha. This was a 2, it's a 5. So tangent of alpha is 5/2. So alpha is going to be tan inverse of 5/2, which the calculator will have to do that for me. Tan inverse of 5 divided by 2 is 1.19 radians. But that's this green angle here, and that's not actually the blue angle I want for my final answer, because that's the rotation from that initial x-axis. So how can I figure it out? Well, like I said, theta and alpha combine to give me the full half circle. So I take the half circle and I subtract away alpha. That's going to give me the theta I'm actually looking for. All right, so pi minus 1.19 is theta. All right, and that is going to be pi minus 1.19, 1.95. All right, so now I know my point in polar. I go a distance of 5.39 along the angle 1.95. All right, so once you're out of quadrant 1, you have to think about how your right triangle actually relates to the angle that you're trying to find. All right, in quadrant 2 like this, you're going to have to kind of subtract it from pi, as similar stuff we've done before. If you're in quadrant 3, your angle theta gets added. If you're in quadrant 4, you're going to take the whole circle and kind of subtract away. All right, so it depends on what quadrant you're in. You have to do slightly different things in order to figure out exactly what that theta value is. All right, so in this one, you're going to convert 3, -1 into polar. All right, so this is how you can do this one. All right, there's multiple different ways to do it, which is actually interesting for this. There's multiple different answers based on how angles work. All right, so the first one, no different. If I want to find the distance I'm traveling, I'm finding that r squared, and I'm getting the square root of 10 because I have a 3 and a 1, and that's 3.16. All right, so you can see in both my answers, I have 3.16 for my r, that distance I'm traveling. There's 2 different ways I can talk about the actual angle theta. So the first one is the positive angle. I start on the x-axis and I rotate around to there. All right, so that angle there is the theta that I'm trying to find. I can use my right triangle to figure out this angle alpha. Again, you can see the blue and the green make the full circle 2 pi. So I subtract away that alpha, I'm going to get theta. All right, so that's how I got this answer, 5.96. The full circle, subtract away that little alpha part, and I get the blue part I actually want. The alternative is, instead of thinking about my angle rotating this way, or in the counterclockwise direction, I could just rotate from here straight down and get my angle there. And that would just be a negative angle. And I know that angle is 0.32, so I'm just going to rotate down 0.32. All right, so these 2 angles that I got are technically the same angle. They both go in this direction. But one is thinking about it as a rotation counterclockwise. The other is a rotation clockwise. All right, they both get me to this red point here, so they both are right answers, and neither one's more right than the other. And the last one, convert the point square root of 2, square root of 2 into polar coordinates. All right, for some reason, I don't know why I did this, the angles here in degrees. All right, so for some reason I did that. All right, the angles in degrees. I would say anything, try to figure out what this point is in polar coordinates.